Porthcawl is a very good place to study rock formations. You've got a very high tidal range, which means a lot of rock is exposed. The rock here is Carboniferous limestone, which was laid down about 360 million years ago when this area was a shallow tropical sea. And basically this is a kind of ooze made of silt and the remains of marine animals which were deposited on the seabed, and as the sea level rose, more and more deposits were laid down so that they are thousands of feet thick in places. Here you can see that the layers of deposits are fairly flat, but in many areas they've been twisted so that they're vertical or even occasionally upside down. But fortunately we can see them more or less as they were laid down 360 million years ago. 360 million years is a very long time, and these deposits have been subjected to all sorts of different conditions. They've been covered by thousands of meters of other deposits. They've been pushed out from below the sea onto the land and been eroded by wind and rain and ice. Then they'll have been submerged again under the sea and eroded by the sea. But occasionally you find layers exposed which are probably more or less as they were laid down. And I think this lumpy surface here is the remains of a coral reef. We know there are corals here because in the rocks you can find fossilized remains of corals preserved in the rock. Sometimes the rock has been eroded in such a way that a cross-section can be found of fossil corals, and here's a good example, beautifully preserved in the rock. Here's a different kind of fossilized coral. Embedded in the rock here is the remains of a brachiopod, a kind of primitive mollusk. Small cracks in the limestone become infilled with calcite, which is basically calcium carbonate. This is dissolved by rainwater from the limestone and becomes recrystallized in the cracks as calcite. It's the same material that forms stalactites and stalagmites in caves. There are many other minerals that occur in the limestone, but calcite is relatively soft. If you can scratch the material with a key or with a coin, then it's probably calcite. Here's another type of fossil, a mollusk more like a snail. In this case the original shell has been broken down and replaced by the mineral calcite. Because of the huge pressures created by movements of the Earth's crust, you often get major cracks in the rocks. We call them faults. And here we've got a double fault in that there are two cracks, and it looks as though the whole central section of rock has dropped by about 10 meters from the level around it. Here's an example of infilling. A crack in the rocks in the limestone has been infilled by other material, probably millions of years later. The material that's created the infill is a mixture of stones of different kinds cemented together by calcium carbonate in the form of calcite, which is the white mineral. Occasionally you'll find veins of quartz in the rock. These are created when there was volcanic activity deep below the Earth's crust, and very hot molten rock was pushed up into these cracks and gradually crystallized. The quartz is much harder than calcite. You can't scratch it with metal, so you can tell the difference between quartz and calcite in that way. Notice that the rock alongside the quartz vein is darker. It's been changed by the intense heat of the molten rock pushing up into the crack. And if you look very carefully, close up, you can see a dark grey mineral and this mineral is galena, which is lead ore, and when there was a sufficient quantity of it, it was mined to get lead. And of course, associated with these veins also sometimes to be other metals such as silver and even gold. And amongst the rocks near the top of the beach, you can find a row of bricks. These are the remains of a wartime lookout post, which was here during the Second World War to look out for enemy ships and submarines. This is what some people call a sand volcano. It's simply a spring coming from the limestone below the sand, and it's fresh water bubbling up and running across the beach. You can quite often see gulls hanging around these areas because they like to bathe and drink in the fresh water. About a mile beyond Rest Bay you come to Pink Bay, so called because of the pinkish colour of the rocks, and we'll have a closer look at those rocks now. The rock here at Pink Bay is a conglomerate. You can see that it's made up of rounded stones in a reddish matrix, and this was laid down on top of the limestone in the Triassic era, so it's known as a Triassic conglomerate. This rock was laid down about 200 million years ago in the Triassic era. There's actually a gap of about 160 million years between the Carboniferous limestone, which is directly underneath this. Normally you'd expect a continuous sequence as newer deposits were laid down on top of each other, but in this case there's a gap, and this is because the previous layers which were laid down on top of the limestone have been eroded away, and these deposits have been put down later on. It's what's known by geologists as an unconformity. When this material was laid down, this was a hot, arid desert with a lot of loose stone and a reddish, sandy material that you would get in many modern deserts. During periods of occasional heavy rainfall, there'd be floods, and sheets of this mixed material with sand and mud and stones would be washed down into gullies or wadis, as they'd be called nowadays in deserts. And this built up in layers that eventually solidified, became cemented together to produce what we see now. Here the sea has eroded away the Triassic conglomerate and produced these marvellous colours and textures, almost like marble. Where the sea meets the land, it carves what's called a wave-cut platform, a relatively level surface which cuts across the existing rock strata. We see one here being formed at the present day, and over here you can see a fairly flat level area which is a former sea level, probably created sometime in the last 5 million years or so, when the sea was about 10-20 meters above where it is now. At the top of the beach you've got limestone, but then above the limestone, just before you get onto the grass, there's an area of jumbled stones of all different kinds, and if you look closely, these are not limestone, they are sandstones of various types, and these look to me like glacial till, as it's called, which is material carried from maybe many miles away by glaciers during the last ice ages. Local geological experts say that the ice didn't come this far south, but this to me is evidence that it probably did.